Is energy absorbed or released during phase changes in matter? Have you ever wondered what happens to energy when matter changes from one state to another? This question is key to understanding how the world around us works. When matter undergoes a phase change, energy plays a significant role, and whether it is absorbed or released depends on the direction of that change. Let's break it down. When matter transitions from a less energetic phase to a more energetic phase, energy is absorbed. For example, when ice melts into water, energy is taken in. This energy helps break the bonds holding the solid particles together, allowing them to move freely as a liquid. Similarly, when water vaporizes into steam, energy is absorbed to overcome the forces between the liquid particles. Interestingly, during these phase changes, the temperature remains constant. The energy input goes into changing the state rather than increasing the temperature. This is why ice can melt at 0 degrees Celsius without the temperature rising until all the ice has turned into water. Now let's consider the opposite scenario. When matter changes from a more energetic phase to a less energetic phase, energy is released. For instance, when steam condenses back into water, it releases energy. This energy releases can be felt as heat. When water freezes into ice, it also releases heat to the surroundings, even though its temperature stays at 0 degrees Celsius until all the water has solidified. This energy absorbed or released during phase changes is known as latent heat. It is a fundamental concept in thermodynamics. Understanding how energy transfer occurs during these transitions helps us in many practical applications. For example, in climate control and refrigeration, knowing how energy changes during phase transitions is essential. Phase change materials are designed to absorb heat when they melt and releases it when they freeze. This helps regulate temperatures in buildings and electronic devices effectively. In summary, energy is absorbed during phase changes that increase the energy state of matter, like melting and vaporization. Conversely, energy is released during phase changes that decrease the energy state, such as freezing and condensation. This principle is vital to thermodynamics and explains why temperature remains constant during a phase change, despite heat being transferred.